Hello, today I'm going to discuss about the multi-threading concept. Coming to the multi-threading concept, first I would like to describe about multitasking. What is multitasking? Multitasking is the concept in which we execute something simultaneously, and that is called multitasking. Like we are doing parallelly two things, like we are listening song and are also developing the program. So in this we are doing multitasking in our system. So this kind of a concept is called multitasking. There are two types of multitasking. One is the process based multitasking, another is the thread based multitasking. Coming to the process based multitasking, process based multitasking has some subdivision. I mean to say that process based multitasking have their own data segment, in the sense that on own data segment of the parent process. In process based multitasking, it has their own memory address. In process based multitasking, what we are going to do, we are doing something simultaneously. Like in Eclipse, we are developing on some program, and during developing this program we are also listening the song. So in this, one process is your music player, and one process is your editor, that something like Eclipse or Edit plus plus, in which we are developing something. So coming to the thread based multitasking, in thread based multitasking we are executing, we are performing something simultaneously, but it is the part of the same process or same program. In Coming to the point that now we are not using process based multitasking, we are mainly focusing on thread based multitasking, because thread based multitasking is very convenient, very flexible, because threads are very lightweight. So I would like to put some light on those things, why we use multi multi-thread based multi-threading based multitasking, not extensively used process based multitasking. There are some reason behind this, that is, threads are subdivision of process. One or more thread run in context of process, but process are independent to each other. So if we want to do something, that we need to open several process, so it will share the memory address of the CPU, which reduces the performance of the CPU process. Coming to the process, their process has copy of the data segment of the parent process, while a thread has direct access to the data segment of its process, because process is a part is the part of that particular process have their own address, while threads share the address space of process creation need whole lot of stuff to be done, while might copy the data segment of the parent access and all. But while developing a thread, it is very easily not need to do that kind of stuff. Process are easily communicate with child process, but inter-thread communication in process, it is very difficult. So while using thread, we can easily achieve inter-thread communication by using wait, notify, and notify method, which we discuss later. Now coming to the another point, process shared system resource like heap memory, and while shares the temporary memory, that is the stack. And one more very important point, all threads have their own stack, like the main is a thread, main has their own stack. Like if we create a one process, that is by using a run method, then in the JVM will create a new stack for that particular process. So these are the point that by using process we face some kind of difficulties, but threads because threads are very lightweight, where process is very heavyweight. So there are some there are some thing that which in process there is some pros. That's why we neglect to use that process based multitasking, or we are using mainly multi-thread based multitasking. Coming to the multi-threading, there are two ways to create threads like in our Java program. One is the by implementing runnable interface, and another is the by extending thread class. Runnable is the interface in which it is the interface in which run method is defined, and thread is the extended class. It is a part of a object class, and this thread class internally implements a runnable interface. Now, while creating, coming to the thread-based multitasking. In thread-based multitasking, first we need to extend the thread. In that particular thread, there is a one method that is start method. Once we created one thread by extending this class, that thread class, then after we need to call the uh, start method. Once we just like we have created an object that is like my thread t equal to new t equal to new my thread, and then after t dot start. Once we did this one, then after automatically start method goes to the run method. There is a two run method. One method run method which is kept in the runnable interface, which has empty implementation. So we need to always override the run method, and we have to provide our own business logic inside that particular run method. So there it is very essential point. Always we need to override run method. If we are not do such kind of a thing, then it will nothing or would be happen that you will get the empty output. So coming to by using runnable interface, once when we using implementing the runnable interface, mainly what happened in runnable interface, that we need to pass the object of that particular runnable interface class, like my thread implements runnable, and then after we have to create an object of that my thread, that is my thread t equal to my uh, uh, my thread uh, empty equal to new my thread, and then after we need to create one thread class object, that is thread t1 equal to new thread. Okay, and inside that new thread we need to pass the object of that particular runnable class, that which implementing like my thread empty we need to pass inside that my new thread inside that bracket, and then after we have to call then after we are eligible to call that thread method, that start method, because start method implementation having that thread class, and thread class is a not direct part of that runnable interface. So we need to pass the object. So once we call that t dot start, then automatically internally start method has calling of run method, and it will goes to the run method, and then after whatever business logic we have written inside this particular run method, that particular logic start executing. So one very essential point is here that once we have executed that particular multi-threading programming multi-thread program one multi-thread program, then output is unpredictable, because there is a one thing inside a JVM, that is thread scheduler. So thread scheduler has some kind of a algorithm which schedules all the threads according to some random manner. Like sometimes it executes thread, like we have multiple threads, thread 1, thread 2, thread 3. In this case, thread scheduler will pick any one of them, like thread T3. T3 thread scheduler start executing thread T3, and in between it will again start execute the main thread. So simultaneously the execution is going on. So we cannot predict the exact output of the of any threaded multi-threading environment program. So coming to one more point there, why when we use thread, when we need to uh, extend that thread class, and when we need to implement runnable interface, while using when we use when should we use that thread class? When we need to modify the run method and other methods, then that time we need to extend that thread class. When there is only use of run method, on I mean to say that when only we need to modify the run method, then that particular case we only use that runnable interface. So there is some other points also, that which one is efficient, thread extending thread is efficient, or implementing thread is efficient. So I would like to tell that by using runnable interface, it is more efficient as compared to extending that particular thread class. Mm. There is some points that I would like to highlight, that multiple inheritance is not allowed in Java. Why? Because once we have extend any thread, any class, then after we are not able to extend one more class. So at a time we can extend only one class. So if there is a requirement to extend one more class, then we are not able to do such. But by implementing runnable interface, we have a one option, that we can implement or extend one more class, or we can add or incorporate more than one class. So it's better to use implement runnable interface. As compared to the thread safety, runnable interface using the same object, like whatever we are creating, like class like ithread empty equal to new runnable, then after we need not to create again one runnable object. One only using only one runnable object, we can create multiple thread, like thread t1, thread 2, thread t2, thread only we need to pass that particular object of runnable. Here it is more safety, because we are creating only one object and multiple, and using in multiple thread. So here is we can achieve the thread safety. But in while using a thread class, we are not able to do such. So implementing runnable method in interface, implementing runnable is lightweight operation. Why? Because while implementing runnable interface, in runnable interface there is only one method, that is run method. But in extending, while extending thread class, there are multiple features. So we, if that particular feature is not required in our program, then but we are extending, so forcefully we need to use that particular features, I mean to say that features. So uh, as compared to extending thread, implementing runnable is a lightweight operation. uh, Most of the programmers always they always recommend to us to coding to interface, because interface are more likely to be, because in interface we can extend more than one class. Now these are the very essential point, that whatever I have discussed right now. And coming to the another point, mm, life cycle of a thread. So there are some states in while using that life cycle of a thread. First of all, the I would like to say that is one is the new, second is the runnable new state, then after start, and then after runnable, then after that state. So I will come one by one and explain the whole life cycle of a thread. So first of all, I would like to explain that there are following states in while using that particular thread. They are following steps. One is the new, and another is the runnable, another is the running, then after waiting state, then after terminated or dead state. First of all, when we create an instance of that particular thread, that is the born state, or we call that running state, sorry, new state or born state. Once we have created that particular object of that particular thread class, then after we will just use start method, t dot start. Once we have do this, it means it will come inside a runnable state. It means your particular thread is ready to start to run. Then after once t dot start is going to execute, it will internally call run method, and then after your thread is now in the running state, and it is ready to execute, and now it is executing. Sorry, it is not ready to execute, it is executing now. Once in between, once your run method execution got over, then after it automatically goes to the dead state. But sometimes we are interrupting our thread, like using some methods like wait method, sleep method. Once while running, when we interrupt our thread, like by using sleep method, it will go to the waiting state, and it is waiting till some amount of time. Once that time is got over, then after automatically it goes to the runnable state, and then after that particular thread is waiting for the thread scheduler, when thread scheduler is going to uh, schedule that particular thread. So likewise it is going on that life cycle of the thread. So now there are some essential methods while using thread environment we are using, like sleep method, join method, then after wait, notify and notify all, yield, and one more concept is there, synchronized. So I will come one by one. Just like sleep method. Sleep method is a static method in which we are using like we are just we want to sleep some particular date for some amount of time, like some period of time, like 1 millisecond, or 1000 millisecond, or 1 second, 2 second. So we can do it just like t dot sleep. Once we have do it, it will automatically goes to the waiting state. Once your time got over, once that particular specified time got over, then it automatically comes to the runnable state, and then after it will just waiting just once it will got it schedule, then it will complete its running, and then after goes to the dead state. Coming to the next point, that is yield method. Yield method is nothing in which JVM gives you the gives you the hint that some that particular thread wants to yield. Then in that case we just call the yield method. Yield method is not going to the waiting state. It goes to the runnable state. It is a very important point, and it is the one of the basic difference between sleep and yield. Yield method goes to the runnable state, not goes to the waiting state, but sleep method goes to the waiting state. So now another very important point is the wait, notify and notify all. These three methods are belongs from the object class, and a very essential point is there, why we use wait, notify and notify all, because wait, notify all is the part of a object class, so they have a monitor, but thread objects don't have a monitor. So these thread class objects are not able to hold the lock. So we use that particular object notify sorry, wait, notify or notify all, because they have a monitor and they can use to hold the lock. So wait method is just wait that particular thread, and then after notify all is used to just give you the push, now it's your time to uh, to come out from your sleep. So now coming to the join method is a very essential, very important method. With the help of join method, we can just get the exact output that we want. Like as I told that as I said that by using while using multi-threading environment, we cannot predict the exact output. If we want to the exact output, then we can use join method, because once thread scheduler start executing like thread 3 T3, then after you want to execute T2. So join method, using join method, we wait till T3 uh, T3 thread execution got over. Then after it automatically, once T3 got execution got over, T2 joined that particular row or particular line of the execution. So according to it, it will just maintain the exact order. Coming to the synchronization is the very important point. By using synchronization, we can like in we have a one object, and it has multiple threads. So here that all three threads want to execute or take that particular resource at a time. So there is that data inconsistency, data corruption kind of a thing is going to happen. So due to avoid these kind of things, we use synchronized keyword. Synchronized keyword means that it will like one object resource is there and multiple threads are there. So one thread will come, and then the one by it will just execute things one by one. It means that once T3 get the object lock, then after T3 will execute, will take the resource, uh, will work with that particular resource until it will complete it works. Once it will complete work with that particular object resource, automatically it will release the lock, and then after T2 or either T2 or T1, one of them get that particular lock, and it will enter that particular synchronized method or synchronized block, and it will execute till that particular execution got over, and T1 is now going to wait state. Once that particular execution got over, then after T1 again join the take the lock, and then after it will complete its execution. So by using a synchronized method, we are achieving the one by one execution. I mean to say that thread will execute one by one. It means that it will maintain the that data consistency, and it will not lead to any data corruption. So these are the main very important points that I have discussed in thread. These are the very basic, and I hope you like my video. Thank you. Thank you very much.